Hi guys, so we are solving this problem which is under the factoring type, and it's a bit of a challenging one in the sense that it took me at least 2 tries to figure it out. So if you haven't already, try it on your own, and then if you can figure it out, you can come watch this video. So here's the few things I noticed about this thing. So first of all, there's 3 different angles, which is a problem. So we're definitely going to need some identities that allow us to change these angles. The other thing I noticed is that there's a negative here. So since everything's being added or subtracted, I'm just going to change this one and put it on the other side so that I have addition everywhere. There's probably other ways of doing this, but I know this method works, so let's just do it. So we're going to get cos of 2x plus cos of 6x is equal to 1 plus cos of 8x. So since everything is addition, the first formula I'm going to need is the sum to product. So I'm going to modify all these expressions so that instead of having addition, I have multiplication. So for this side here, we have the sum of 2 coses. So I suggest you take a moment and just go check the sheet where it has all of the identities. And if you do so, you'll see that when you add 2 coses, what we're going to do now is we're going to multiply 2 coses with 2. And then for the first angle, it's going to be the sum of the 2 angles divided by 2. So 2 plus 6 is 8. 8 divided by 2 is 4. So 4x. And then the other one is going to be the subtraction of the 2 angles. You really have the choice between subtracting 2x from 6x or 6x from 2x. I'm going to do 6x minus 2x just so that it's positive. So 6x minus 2x is going to be 4. 4 divided by 2 is 2. So 2x's. This doesn't show very well. 2x's is equal to. Now for this side, there's again a couple of things we can do. One thing I noticed is the fact that this is 8x. Therefore, it's divisible by 2. And we do have a formula for double angles. And if I do divide it by 2, then I'm going to get a 4x, which I already have in my equation. So having another 4x would probably be a good thing. So this other formula I'm going to use for the right-hand side is going to be the double angle. So for double angle, we get the one is going to stay. I really want this to be black. Okay, so one's going to stay. And then the rest is going to become 2 cos squared of half of the angle, so 4x, minus 1. And then some things are going to cancel out, which is super nice. So the minus 1 is gone. Then we can divide both equations by 2, and the 2's are gone. So we are just left with this. Now, if you notice, we have cos of 4x and cos of 4x, which is basically what we wanted. One thing you don't want to do is divide both sides by cos of 4x. The reason why you don't want to do that is because it might be equal to 0, and you're never allowed to divide by 0. So because of that, there's only one thing we can do really, which is to subtract cos squared of 4x. So the first term is going to be the same, but now we're going to have everything on one side. So this is not what I wanted to write. A minus cos squared of 4x. It's a factoring problem, so it does make sense that we end up with something that we can factor. So let's factor cos of 4x on right here and be left with cos of 2x minus cos of 4x right here. At this point, it's either that cos of 4x is equal to 0 or that cos of 2x minus cos of 4x is equal to 0. So we're just going to split this equation in 2 parts and solve each part. First one being when cos of 4x is equal to 0. Drawing a small circle, we remember that cosine means that we're looking at the x-axis of the trig circle. So if it is that the x coordinate is 0, it's along this line here. So there's 2 angles that are possible, pi over 2 and 3 pi over 2. I can, however, merge them into the same angle because they're just a difference of pi between them. So really, it's just pi over 2 plus pi n. So if you want to understand why this works, is because if n is equal to 0, then you get pi over 2. If n is equal to 1, then we get pi over 2 plus pi, which is going to be 3 pi over 2. So this next angle here. And then when n is equal to 2, we are going back all the way up here and so on. So this is really all we need. Now we just need to isolate x. So the first solution that works for this problem is for pi over 8, because I divide by 4, plus pi over 4 times n. Ta-da. Second thing we need to look at is for this part here of the equation. So we want to put this equal to 0 now. So cos of 2x minus cos of 4x is equal to 0. We have different angles. So again, same problem as we had at the beginning. We got to change one of these angles. And since one is the double of the other, it calls very clearly for a double angle formula again. So let's do it. So the first cosine stays the same. The second one, we're going to change it using that formula, which is 2 times cos squared of half of the angle. So 2x minus 1 is equal to 0. The next thing that should jump in your face, the fact that we have a square here and no square here. This is just a 1. So when we have that, it's obviously a substitution. So let's do our substitution right away. I'm going to set t to be equal to cos of 2x. And then since cosine can only really go between minus 1 and 1, I'm going to write this down to make sure that I reject any solution that doesn't make any sense given the context of the problem. And then substituting, we should get, I'm going to put the square first. So minus 2t squared, and then plus t plus 1, because the two minuses will become a positive, equals to 0. I do not like having a negative in front here. So I'm just going to quickly divide by 1. So 2t squared minus t minus 1 is equal to 0. Doing the discriminant, you will get two possible values. So I'm going to put the first one here. So t is equal to 1 should be the first one you get, or second one, depending if you subtract or add first. If t is equal to 1, it means that cos of 2x is equal to 1. Quickly drawing my circle. So cosine is again an x value. If it's an x value, it means that it's right here. This is my 1. So we really just have one point on the circle where cosine is equal to 1. And that is when the angle is 0. So we should get we should get 2x is equal to 0 plus 2 pi n. And dividing by 2, we get just pi n. Notice I call this one x2 because we already have x1 up here. The last thing we have is for t is equal to 1 minus 1/2. When you did your discriminant, this should be the second root you got. And here again, drawing a circle, I'm going to go right on the same one I was using. I'm going to use blue this time. So this is, again, cos of 2x is equal to minus 1/2. So minus 1/2 is this middle value here, and there's two more on it. So this is the one I'm interested in. And I know that there's two more values on this. So we have one here and one here. So it means that the angle made with the origin here is the biggest one. So it should be a 60-degree angle, or pi over 3. And the pi over 3 angle is right here. I need to know the one that goes around like that. I know that the full angle, so if I would go until the end, is pi. Therefore, to find this one, I should have pi minus pi over 3. I'm going to go quickly because my time is running out. And then the one down here that goes all the way around like this until this angle will be pi plus pi over 3. So the two possible answers will be here, 2x. I really want black for this. Please just do what I want. Okay. So we're going to have 2x is equal to 2 pi over 3 for the first one, plus 2 pi n. And then dividing by 2 on each side, we get x3 is equal to pi over 3 plus pi n